We spend so much time talking about cloud security, trying to protect our data, but what if I told you there's this fundamental gap in most security strategies, a tiny moment in time where your most sensitive information is just completely exposed? Well, today, we're going to find that gap, and more importantly, we're going to figure out how to close it for good. So, you've done all the right things, right? Your databases are encrypted solid, your network connections, all locked down with TLS. But let me ask you this. Is your data truly safe? Because there's a specific moment in its life cycle where pretty much all of that strong encryption is actually designed to just turn off. Look, we're all familiar with protecting data in two of its three states. First, you've got data at rest, like your encrypted database, just sitting there. Then there's data in transit. That's your info zipping across the network, all secured by TLS. But what about that third, absolutely critical state, data in use? This is the exact moment a processor is actively working with your information. And, well, that's the source of a major vulnerability. And that right there brings us to what we're calling the cloud's hidden gap. It's a vulnerability that doesn't exist in your storage or out on the network, but deep, deep inside the processor itself. Okay, so here's the core of the problem. For a CPU to actually do anything with your sensitive information, to process it, to run calculations, that data has to be temporarily unencrypted while it's in memory. And during that critical, tiny window of time, it's potentially visible to the underlying cloud infrastructure. I'm talking about things like the hypervisor, which is the software running all the virtual machines. That little window of exposure, that is the gap. So how do we close this thing? The entire industry is starting to rally around this approach called confidential computing, and it's designed to do one thing: protect your data while it's being processed. Now, the magic behind confidential computing is something called a trusted execution environment, or a TEE. The easiest way to think about it is like a secure black box, a totally private and isolated area right inside the CPU itself. Any code and data that goes into this TEE is completely, and I mean completely, shielded from the rest of the system. Let's break this down with an analogy. Imagine your app says to the CPU, "Hey, I need a secure space to work." The processor instantly creates this encrypted vault right there in memory. Your sensitive data then gets moved inside this vault for processing, and the key to unlock it, it's held by the CPU itself. This means everyone else is locked out, and yes, that includes the cloud provider. They simply cannot peek inside. And here's the best part. This isn't some far-off futuristic theory. It's a real, powerful new security shield that's available today. So let's take a look at what this actually looks like in the real world. Microsoft has just rolled out a new line of confidential virtual machines, and they're powered by the latest 4th-gen AMD EPYC processors. The key technology here is called SEV-SNP. Now, that stands for Secure Encrypted Virtualization with Secure Nested Paging, which I know is a mouthful. It's really just a technical way of saying the hardware itself creates and protects that secure vault for your entire virtual machine. And they're offering two main flavors to start. First, you've got the DCAST v6 series. Think of this as your general-purpose workhorse for all kinds of sensitive workloads. But if you're dealing with massive in-memory datasets, like databases just packed with personally identifiable information, PII, or protected health information, PHI, then the memory-optimized eCast v6 series is going to be the one for you. But here's what makes this a real game changer. It's all about how the encryption keys are handled. These aren't just variables sitting in software somewhere. No, they are physically generated and protected by a dedicated processor that's built right into the CPU. What that means is that no software, not the hypervisor, not the host operating system, nothing, can possibly read them. Okay, cool tech, right? But what does this actually mean for you, for your business? Why is this such a big deal? Let's break down why this upgrade really truly matters. This really represents a fundamental shift in the cloud trust model. Before, you basically had to trust your cloud provider not to look at your data. With hardware-based encryption, trust is no longer required. It's not part of the equation. The system is designed from the ground up to deny access, even to a privileged cloud operator with the highest level of admin rights. Your virtual machine becomes a true black box that nobody else can open. So what does it take to get this incredible level of security? How much refactoring and code rewriting do you have to do to migrate your existing apps? This is the most amazing part. Are you ready? Zero. Absolutely none. You can lift and shift your current workloads over to these new confidential VMs without changing a single line of code. And that makes this technology completely business-ready right now. You get better performance and better price performance than the previous generation. The migration is totally seamless, and it's purpose-built for industries that handle the most sensitive data out there. It finally gets rid of that friction between adopting cutting-edge security and just getting your work done. So when you put all of this together, you're not just looking at a cool new product. You're really looking at the future of data privacy in the cloud. At the end of the day, here's the key takeaway. Confidential computing finally closes that hidden security gap we talked about at the beginning. It completes the whole data protection picture. For the first time ever, we can build a true three-state protection strategy in the cloud, securing our data at rest, in transit, and now, finally, in use. So I'm going to leave you with this one final thought to chew on. In an age where data is constantly being processed and breaches are, let's face it, way too common, we have to ask ourselves, if our data isn't protected during its most vulnerable moment while it's actually being used, is it truly protected at all?